Alright, here we have the first lecture of Unit 3, which will correspond to Section 4.1 from the textbook. So just a heads up, a large portion of this unit is going to be based on Chapter 4 from the textbook. And the topic of this lecture is linear functions. And we're going to open up with slope. So the slope of a line describes that line's rate of change. And every line has a constant rate of change, therefore the slope itself is a constant. Now we typically use the letter m to represent slope, and slope is change in y divided by change in x, as you can see. Now this is should look very familiar to you. It's just the average rate of change formula. All right, it's the same exact thing. If you think of your y's as outputs and your x's as inputs, it's identical. And if we want to think about this visually, change in y divided by change in x, we can view that as rise over run. So let's use that rise over run concept in example number 1. So determine the slope. So we want to figure out what's the rate of change going from one point to another point on the line. I'll start with the lower point, and notice I'm going up 2, so I rise 2 over run 3. 1, 2, 3. So you can see I went up 2 and over 3. So that tells you the pitch or steepness or rate of change of this line. Going from point to point, you're going to go up 2 units and over 3 units. Now you can figure that out visually like we just did. You can also figure out with coordinates, which is what we're going to do in example 2, is determine the slope via coordinates. And a lot of students and a lot of people like to label the coordinates. So there's my first point, x1, y1. Here's my second point, x2, y2. And then it's a straightforward application of the formula, y2 minus y1 over x2 minus x1. y2 minus y1 is negative 3 minus 11. And x2 minus x1 is 5 minus negative 2, being wary of the double negative there. And let's go ahead and compute that. So that's going to get us negative 14 divided by 7, which gets us a slope of negative 2. Now, the slope is a very, very, very important measurement or characteristic of a line. It tells us how steep it is, but it also tells us if it's increasing or decreasing. So a positive slope tells us that the line is increasing. A negative slope guarantees that the line is decreasing. So now that we have slope out of the way, we can begin discussing slope-intercept form. Now, slope-intercept form of a linear equation is completed by essentially isolating the y variable or the output variable. So it's basically if you put a linear equation in function form or function notation, it's pretty much going to be in slope-intercept form. So y equals mx plus b is what we call slope-intercept form, and this is where m represents the slope and b represents the y-intercept. Now it's very, very, very important that you distinguish constants from variables, just like when we were working with circles in the previous unit. So m and b represent constants. They are fixed values for any given line, whereas y and x represent variables representing all the varying points on the line. So make sure you don't confuse variables with constants. So let's go ahead and do this example. So if we look at this, the coefficient of the x is slope. So we know the slope, which is represented by the letter m, is negative 3/4. So I know this line is decreasing because it's negative. And the y-intercept is 5. So I can start with the y-intercept, 1, 2, 3, 4, 5, and mark it. So that tells me that it's going to cross the y-axis at positive 5, and then the next point is going to be down 3 over 4. So I'm going to count down 1, 2, 3, and over 1, 2, 3, 4, and mark the dot. So I just went down 3 over 4. 2 points is sufficient to sketch a unique line, connect the dots, and there's our graph. And as you can see, it is decreasing because the slope is negative. Now let's reverse the direction. Instead of moving from the line to the, moving from the equation to the line, let's move from details or characteristics of the line to determining the equation. So if we want to write the equation, it's going to be structured like this. And we need to figure out that and that. M and B, slope and intercept. So there's two goals here. We need to figure out the slope, and that's actually priority uno. We want to focus on that first. And then second priority is going to be the y-intercept. So for the slope, we're just going to use our definition. y2 minus y1 or x2 minus x1. So we can view that as 19 minus 7 over 11 minus negative 2. And we get a slope of 12 over, let's see here, 12 over 14, which reduces to 6 over 7. Alright, cool. Now, if we go to write our equation, this is what we have so far. Y equals, there's our slope, 6/7 x plus b. And that's what we're missing. We still don't know what the y-intercept is. So what we're going to do is plug in a point. So we go ahead and plug in a point. Now it doesn't matter which point you pick. You can pick the first or the second. I'm going to go ahead and pick the first. Just be careful to not mix up your x and y. So we know the y-coordinate is 7 when the x-coordinate is negative 2. We now have a singular equation with a singular unknown value. We can solve that. We are in the game. So let's go ahead and solve this real quick. We get, let's see here, negative 12/7 plus b. So I can just add 12/7 to both sides. And there we get our solution. So that would be, let me see here, 49 plus 12. Which is 61, so we get 61/7. So there's our equation. Y equals 6/7 x plus 61/7. Remember to represent the variables as variables, so we're writing them as letters, and the constants as constants, so we're writing those as the number that they are for this particular line. And the way we can check our answer is we can take the 11 and 19 and plug it in, see if we get a true statement. If I plug in 11 for x, that's 66/7 plus 61/7, and let's see if we get 19. Hold up. Let me double check on my calculator. I think I mistyped. Stand by. So 6/7 times 11 plus 61/7. Alright, did I make an error? 6/7 is negative 2. That works. Hold on. 11 and 19. There's my mistake. Sorry. Let me go ahead and fix this. Some of you may have noticed. I apologize. I made a miscomputation. 11 plus 2 is 13. So that gives us 12/13 as our slope. Alright. So the process is the same, as my computation was off. So just bear with me for a little bit. So that 6/7 should have been a 12/13. And then you still plug in the number and solve. So that would get us a negative 24/13, and add that to both sides. Alright, so 7 plus 24/13. is 8.85, which reduces to b equals 115 over 13. Here's the correct answer. Sorry, I made an error in computing my slope. So this is why it can be helpful to check sometimes. There we go. That'll do it. And I'm sorry if this looks a little sloppy. I promise we got more examples just like this coming up. But I do want to summarize, when you're writing a linear equation, there's two things you want to focus on: slope and y-intercept. Those are the two goals. And we'll get some more practice with these. But before we do more practice, let's talk about parallel versus perpendicular. So two lines are parallel if they never touch or never intersect. So parallel lines must have the same slope. Two lines are perpendicular if they intersect at a 90-degree angle. The catch with perpendicular lines is they have an opposite and reciprocal slope. So this is the important part you'll want to write down. Parallel implies same slope. They have to have the same slope in order to be parallel. Perpendicular implies slopes are opposite and reciprocal. So again, the slope is key here. Now, let's go ahead and look at this example 1. Now, we need to get the y by itself. Alright, so here we need to go ahead and isolate the y, so just add 3x to both sides. Once we get the y by itself, we can see the slope. So I can see that the first has a slope of 3, the second has a slope of 3, it's the same slope, and therefore can conclude these two lines are parallel. Now, same thing in example 2. We're going to have to isolate first. So, well, to get y by itself for the first equation. So when we do that, and feel free to pause and do this on your own if you need to, you're going to get 2/3 x minus 3. And the second equation is good to go. We don't have to do anything with it. And I want you to look at these two slopes. Notice that they are opposite. One is positive, one is negative. They are opposite and reciprocal. The reciprocal of 2/3 is 3/2. So these two lines are perpendicular. And this last example, notice that we have a slope of 5 versus a slope of 1/5. They are reciprocal but not opposite. You know, one's positive, the other's positive. They're not opposite signs, so these are neither parallel nor perpendicular. Alright, with that out of the way, we can actually do some more examples. So, write the equation of the line that's parallel to y equals 3/4 x plus 2 and passes through that point. So, it's like that example I botched earlier, but the strategy remains the same. We need to figure out slope first and y-intercept. Now we know we are parallel to y equals 3/4 x plus 2. Parallel means same slope. Okay, so the slope of our mystery line is the same as the slope of that line. So I know my slope is 3/4. So at this point, if I go to write the equation, I got y equals 3/4 x plus b. So just like before, we are still missing that y-intercept. So what you do is plug in a point and solve. So we know the y value is 17 when the x value is 16. So all I'm doing there is plugging in a point and solving. So 17 equals 12 plus b. So b equals 5. So we know the slope is 3/4. We know the y-intercept is 5. And there's our equation. Bada bing, bada boom. Cool. Alright, let's look at another example. Write the equation of a line, but it's perpendicular to that given line and passes through the point 11, -3. So slope is always the first priority. And then once we know the slope, we can figure out the y-intercept. So the idea with the slope is we're going to focus on the fact that it's perpendicular. So it's perpendicular to 3x minus 7y equals 21. So we need to figure out the slope of this line. To do so, we want to get y by itself. So we can subtract 3x from both sides. And then divide everything by -7. So that gets us 3/7 x minus 3. So the slope is perpendicular. So that tells us the slope is opposite and reciprocal. Well, this slope is positive, so ours is negative. The reciprocal of 3/7 is 7/3. So we now know that our slope is -7/3. We're halfway done. What remains now is to figure out the y-intercept, and it's the same song and dance as before. Go ahead and plug in that point and solve. So the y value is -3 when the x value is 11. So let's go ahead and solve that. So it's -3 equals -77/3 plus Bravo. So go ahead and add that to both sides. So we got -3 plus 77/3, which gets us 68/3. So there's our equation. Y equals -7/3 x plus 68/3. Alright, and if you want to verify on your own, you can input that point, and you will note that it produces a true statement. So let's go ahead and finish up this lecture by looking at an application. It's asking us to write a linear equation, so we need to figure out our slope and our y-intercept still. But here it's we're just going to kind of think about what the values represent. So slope represents rate of change. Y-intercept in many applications represents the initial value. So what's the rate Alan's earning? Well, 3%, which is 0.03. So he gets 3% of every dollar in sales. So basically gets 3 cents on the dollar for everything that he sells. Now, that's in addition to getting $1,500 per month. So remember, the y-intercept is on the y-axis, which is where the x value is 0. Well, the x value represents his sales. If his sales were 0, then his paycheck will be $1,500. So in other words, his paycheck is determined by this equation, 0.03x plus 1,500, where the 0.03x represents his commission. Notice commission has a variable in it, because commission, how much he makes off commission, varies, right? If he sells more, he gets more. If he sells less, he gets less. But the y-intercept, notice there's no variable there. That's because it's fixed. That represents his base pay. All right, that is linear functions. So guys, I posted some supplemental videos that have plenty of more examples that you're welcome to watch. And this also corresponds to section 4.1 from the textbook if you want to reference that. Keep up the hard work and have a wonderful day.